We're going to talk about using data to model situations. And we're going to go back to equation solving a little bit. This time, though, instead of me telling you, solve this equation by using the quadratic formula, or solve this equation by factoring and solving, I'm just going to give you an equation and you're going to solve it. And so we're going to talk about some methods that we use and how we know what to use to solve when and what we need to do from there. But first, everybody's favorite, let's look at some sets of data. Let's see. Let's say that I gave you I wish I could just give you this table. I don't want to just write this whole table out. Bless you. Okay, let me just put your year. So this chart shows us comparing the year to what the minimum wage was that year. Some of you said 75 cents. I would never work for 75 cents. But then in the next column, you have what the purchasing power is in there. Do y'all know what purchasing power is? So purchasing power has to do, let's do this. Somebody look it up. Somebody look up the definition of it. So I don't.
Hey Siri.
Somebody look it up. Yeah.
What's the definition of purchasing power?
Okay, should I pause while you look this up?
Yeah, hang on.
What is this chapter called?
This lesson is called Modeling and Equation Solving. This chapter is called Functions and Graphs.
All right.
It's what? The value of the sum of money. The value of a sum of money.
So that's like the value of 75.
The financial ability to buy products and services. So think about this. Think about it like with 75 cents you could buy $4.39 worth of stuff. That's the way I look at it.
What?
I said what it's worth.
What it's worth. You're right. Like what it's worth.
You only have
sorry.
75 cents. How can you buy?
All right. So what we're going to be doing here is we're going to be looking at sets like this, and we're going to be doing some analysis on them. And what I mean by that is just answering some questions. Okay. So looking at this, tell me, in what 5-year period did the actual minimum wage increase the most? And that increase was what? $1. That was a big jump, right? For 1 year. That's right. In what year did a worker earning minimum wage have the greatest purchasing power? Because that's actually different. 1970 was the most purchasing power, right? So even though the minimum wage was only $1.60, technically they were making more because they could buy more with what they were making. Does that make sense? Okay, think like cost of living. You get like a cost of living raise whenever you work in a job because it has to account for how stuff increases in price. So they have to bring your pay up. So how much you can buy with what you have. How about this? A worker on minimum wage in 1980 was earning nearly twice as much as a worker on minimum wage in 1970, and yet there was great pressure to raise the minimum wage again. Why? Look at 1970 versus 1980. Why would they want to raise the, even though 310 was the highest it had been in a long time? Why, after that huge increase, did they still want to increase it again? You're exactly right. The purchasing power was $6.47 here, but even at 310, it was only at $5.90. So they didn't feel like it was very fair. Does that make sense? How we're using the chart to answer the questions? Everybody okay on that? Could you then, if I gave you this same chart, let's say I gave you just the first two columns, and I gave you a graph, Could you match up if I gave you some sets of data with some different graphs? Could you match which ones will go with which? In other words, can you graph them? I'm not going to go over that because I think you can do that unless you need me to. Can you match that up? Everybody okay on that? I don't know, y'all. You're looking really funny. Your homework, the first 10 problems, have you match sets of data to graphs to equations. You know how to graph them on your calculator to look and see, right? And then you know how to find the points on the graph. All right, let's talk about some modeling then. Modeling is just another word for word problems. Do y'all remember? They might even still do it, I don't know. One of the pizza places used to do square pizzas. Y'all remember that?
Yeah.
Do they still do it?
What?
They did. Somebody did square pizzas. Okay. Domino's does square pizzas? Rectangles. You work at Pizza Hut? So you still do rectangle pizzas? Why? But they're not all rectangle, right?
Oh, it's just the box one that's the rectangle.
So you just call and say, hey, I want a rectangle pizza today?
No, like you gotta use the
Oh, okay.
Yeah.
Okay, I say all that to set up for this word problem, okay? So you call Pizza Hut, and they say, all right, let's say you call Pizza Hut, and they say that they have a rectangular pizza that is 18 by 24 inches. And it's the same price as a large pizza, a large round pizza that is 24 inches in diameter. Now, first of all, what does diameter mean? Close. So when you're talking circle, a round is circumference, all the way across is diameter. Half of the diameter is called what? Radius. Okay? They're the same price. July said he'll make you either one for the same price. But you want the most pizza for your money, right? Because we're savvy shoppers. We like to save money. Which one gives you the most pizza? Oh my gosh, which one gives you the most pizza for your money? Why? Can we do this mathematically, y'all? Oh my goodness, y'all. I like the rectangle. I'll take the rectangle. Now I want to know which one gives you more pizza. Which one's the better deal? How do I find that out?
Doesn't matter.
What, Alex? Go ahead.
Find the area.
Find the area of each one. You're exactly right. Find the area. How do I find area of a rectangle? 18 times 24. Length times width. You're exactly right. How much pizza area is on my rectangle pizza? Please, somebody. Multiply 18 by 24. 432. 432 square inches of pizza. That's a lot of pizza. How can I find the area of the circular pizza? How do you find the area of a circle? Somebody knows. Pi r squared. What is r? Radius. What is r in this case? 12. So I need pi times 12 squared. So 144 times pi. What does that give you? Somebody with a calculator. 144. What? Where do you, 16? Where do you get the most pizza?
Circle.
The Circle. Which one should you get? The Circle. One day you know why. All right. Questions about that? Could you do that if I set you up, if I gave you a problem and I said, your local pizza place is selling rectangle and circle pizzas?
Now I heard.
Now you could. Okay. Well, as long as you can do it now. Just always get the Circle. All right. I don't know.
It's just so people can buy it.
Maybe people.
Your panel's in standby.
I know you just said
Thank you. All right.